In this problem, we need to solve for x, and to get started, I'm going to subtract 5 from both sides, because before we can deal with the absolute value, we have to have it by itself on one side of the inequality. So I have the absolute value of x plus 7 is less than or equal to 2. Now that is possible. You want to stop and say, is this possible? The absolute value has to be a positive value if it was, say, absolute value of x plus 7 is less than or equal to negative 3. Then you would say, well, that's not possible and there is no solution. So in this case, this is possible. So the next step is to say, well, that means that this value, x plus 7, is either less than or equal to 2. Well, I shouldn't say either. It is less than or equal to 2, but it also must be greater than or equal to negative 2, because it has to be between those two values. If x plus 7 was, say, less than negative 2, if it was negative 5, then its absolute value would be 5. It wouldn't be less than or equal to 2. So it has to be between those two values. So what I did was I took this 2 and I said, let's make this positive here, negative here, because this is a less than or equal to. In the next problem, we'll see what do you do when you have the absolute value is greater than or equal to something. So when it's less than or equal to, you're between two values. And now I solve by subtracting 7 from each side, and we get negative 9 is less than or equal to x, which is less than or equal to negative 5. So we want to write this in interval notation. That would be negative 9 to negative 5 using square brackets because we're including. And to draw this on the number line, put a negative 9, a negative 5, and bracket, bracket, and there you go. Now in the next problem, 30, we have 8 plus the absolute value of 1 minus x over 2 is greater than or equal to 10. Again, I'll start by getting the absolute value by itself. And I have 1 minus x over 2. The absolute value of that is greater than or equal to 2. So that means that the quantity inside the absolute value bars must be either greater than or equal to 2, or it could be less than or equal to negative 2. Because if this whole quantity inside the absolute value bars was equal to negative 5, then that would satisfy this inequality, because we'd take the absolute value of negative 5 and we would say, sure, that's greater than or equal to 2. So we have two possibilities here. So to solve the first inequality, I'll subtract 1 from both sides, and I have negative x over 2 is greater than or equal to 1. And then I can multiply both sides by a negative 2. But remember, when you do that, you have to flip the inequality because we're multiplying by a negative. And I get x is less than or equal to negative 2. For the other inequality, I subtract 1 from both sides, and I get negative x over 2 is less than or equal to negative 3. And again, I multiply both sides by negative 2. And I get x is greater than or equal to 6. So, I'll start by graphing this on the number line. Makes it a little easier to see what's going on. So we have -2 and we have 6. And x is less than or equal to -2 or greater than or equal to 6. So when we write this with interval notation, go from -infinity to 2, close the bracket, union 6 to infinity. And so that would be my solution in interval notation.